Hello, thanks for watching the video and studying your math with us. These videos are intended to accompany but not replace the reading of your text. This episode offers a light review of some of the prerequisite material that is contained in section 1.1. We of course will be dealing with numbers, and some vocabulary is useful. The counting numbers, 1, 2, 3, and so on, are called natural numbers. When we add 0 to this set of numbers, the resulting superset is called the whole numbers. Adding the negatives of the natural numbers to this growing set results in a set that is called the integers. We next add some numbers that reflect not only whole numbers and their negatives, but fractions thereof. This involves ratio of integers, the elements being represented by fractions, or equivalently as terminating or repeating decimals. Here's a terminating decimal, here is a repeating decimal. Here's a fraction 5 over 9, here's another fraction minus 3/8. These are called rational numbers because they're ratios of integers. There are real numbers which do not have terminating and repeating decimal expansions. These are not rational numbers and are called irrational numbers. This is the first time we've created a set of numbers that did not contain everything before. For example, minus 2 is an irrational number because minus 2 can be written as minus 2 over 1. Together, the irrational numbers and rational numbers form a set called the real numbers. Since squaring a real number always results in either a positive number or 0, the square root of negative numbers are not real numbers, and even though they will exist in some of your technical work, are called imaginary numbers. The real numbers do possess an ordering and can be positioned on a number line, all of them, including irrational numbers as well as rational numbers. The point corresponding to 0 is called the origin. The negative numbers go off to the left and the positive numbers go off to the right. Additional notation and terminology associated with this ordering. We use parallel bars to talk about the absolute value of a number, which geometrically means how far is the number from 0. So the absolute value of minus 7 is 7 because minus 7 is 7 units away from 0. Similarly, the absolute value of 6 is 6 units away from 0, so the absolute value of 6 is 6. We also talk about inequalities. We say that A is greater than B, means that A is to the right of B on the number line. Similarly, we can talk about a symbol that we will read as less than from left to right, less than or equal to, and even equal to. Here are some practice exercises that are in your book. I suggest that you pause YouTube, try to work them, and then hit play on YouTube to look at some narrated solutions associated with these problems. Hit pause now. And now we're back here. We can see that minus 4.2 is 4.2 units away from 0. Note where minus 4 is, by the way. And here we're going to do the absolute value first because that's like a parenthesis. So the absolute value of minus 3/4 is positive 3/4, and then we multiply by 1 and we get minus 3/4. And placing these numbers on a number line like this from left to right, we see that minus 5 is less than 4 and 0 is greater than minus. Here we have some more vocabulary. This word is pronounced reciprocal. Every number except 0 has a reciprocal. The reciprocal of a number is 1 divided by that number. If you try to divide by 0, your calculator will give you error messages. It won't usually reference Chuck Norris. But even Chuck Norris can't divide by 0. Chuck Norris is an answer to a quiz problem, though, that you'll have sometime soon, so you want to keep that in mind. Here's some more problems again. You should pause, try these, and then look at the narrated solution. And here we see that we want to represent minus 4 as minus 4 over 1, and 1 as 1 over 1, and then this is 1 over minus 4 over 1. We do the division of the fractions, and when you divide fractions you invert and multiply, so the answer to that one should have been negative 1/4. Similarly here we take 1 divided by 3 over 8, we invert and multiply, and we get 8 over 3. Many times in technical work we will have units associated with our answers, and your answers are not going to be complete without the proper units. Points will be deducted. Moreover, as this NASA example describes, failing to properly handle units can in fact be catastrophic. I also would recommend that you take a glance at Appendix B. It won't be the last time you will glance at that appendix. Finally, we often find letters in formulas and such. And so these representation of numbers by letters are called literal numbers. A good example, we have variables and constants, but a good example of this is the equation that you know about the slope-intercept formula for the equation of a line. Here x and y are considered to be variables, and m and b are going to be constants associated with a specific line, the slope and the y-intercept respectively. So that's about it for chapter 1.1. Remember, time is precious. Each day must count. Doing the math will make you strong. And I will see you in class.